All right, everyone, number 2 says solve the absolute value of x minus 3 equals 2x minus 3. And first, we want to solve it algebraically. So what we do first is we set up our two equations. One where the right side of the function is the same and one where the right side of the function is negative. So I want you to press pause, try to set up the two equations, and try to solve both equations. So I hope you did it. We would say x minus 3 equals the same, and one where we have x minus 3 equals the negative 2x minus 3. So now I'm going to move all of my x's to one side. So I'm going to subtract the 2x, so I have negative x. I'm going to add the 3, so equals 0, so x equals 0. And then on the other side, I'm going to distribute the negative. So I have x minus 3 equals negative 2x plus 3. I'm going to add the 2x over. I'm going to add the 3 over. So I have x equals 2. Now we need to double check and see if we have any extraneous solutions. So when we check this one, if I plug in 0, I would have 0 minus 3 equals 2 times 0 minus 3. So I would have the absolute value of negative 3 equals negative 3. No, that doesn't work. So this will not be a solution. And if we check this other one, we have the absolute value of 2 minus 3 equals 2 times 2 minus 3. So we have the absolute value of negative 1. Does that equal 4 minus 3 is 1? Yes, that works. So x equals 2 is a solution. Okay, so now what we should do is we should solve this graphically. So for b, I want you to draw the first equation, which is absolute value of x minus 3. And then I want you to draw the second equation, which is 2x minus 3. So press pause and draw those. Okay, so for the first function, I did it in green. It's an absolute value function that has been translated to the right by 3. And the second function I did in pink. It's a linear function where the y-intercept is negative 3 and the slope is 2. And we can visually see that there is only one solution, and then that is when x is 2, and we can see that y is 1. So the only solution is x equals 2, okay? Now, for part C, it says compare and contrast the strengths and weaknesses of each method. So algebraic and then graphing. Algebraic, it's a little bit more exact. Like if we graphed it and maybe the x values didn't meet at a specific point, with the equation we would find that exact point. It might be a little bit faster. And with graphing, it's a lot more visual. You can see the number of solutions. And finally, it's not necessarily exact. Again, if it did not meet at an exact point, you would have to estimate, whereas algebraically, you would find the exact point. I hope that helped everyone.